Welcome back to Tu Akedemy. We're going to talk about continuous function part 3. This time we're going to teach you about the different types of discontinuous function. Discontinuous function have 3. And that's one. I only remember 3 to be honest. So the first one is removable discontinuity. Removable. Removable. Okay. You know what is this discontinuity? Let's say this is the graph, right? And then since this one you cut it off and the graph turns into this. That is removable. Then the jump discontinuity. Jump discontinuity is pretty self-explanatory. It jumps, such as your graph is like this, but then since the limit is different, you go this and this. You see, it's a big gap. You jump. And then the next one is infinity. Infinity is easiest to spot. This when the things are different and then one goes back. Whooshoo! I go infinity. I go infinity. Not connected at all. So these are the discontinuous graph, the 3 different types. Now we're gonna teach you how to spot this different stuff. So if you remember the last question we made last time, f of x equal to x squared, x plus 1, x minus 4 squared is plus 5. Then it's if x is smaller than 1, if x is equal to or bigger than 1, well, smaller than 4, or x is equal to 4. If x is bigger than 4, okay, this is what I'm saying. If x is bigger or equal to 4, and then we got x equals 1. Okay, we're solving here. So f of 1, we find the normal function f of 1, which is 1 equal to 1. So it's this one, x plus 1. 1 equals x plus 1 equals 1 plus 1 equals 2. And now we get the limit. Since this is piecewise, we limit from both sides. X plus 1 from the less than the less than 1 is this one, x squared equals 1 squared equals 1. We already see the difference, huh? Now let's limit of x approaches 1, f of 1, f of x, f of x. Then as approaching big side. So what's bigger than 1? Closest thing bigger than 1 here. X is bigger than 1. So we use this one, x plus 1. X plus 1 equals 1 plus 1 equals you 2. You see, the limit doesn't exist. So what kind of discontinuity this is? If the limit doesn't exist while this exists, then this is jump continuity. Because remember, limit tells you, like, let's say approaching 0. What happens when x approaches 0? Here. And you can see that here and here they're connected. But for jump, because the limit is different, and let's say 1 is 1, 1 is 2. Let's say as it approaches 1 here, but then as it approaches 1, it gives you 1, it's there. But as it approaches 1 from the big side, from right side, it goes on to 2, which means from the big side, it goes here 2. See that? It is not connected. There's a jump. So this is jump continuity. For infinity, it's basically just if the limits 1 is negative, 1 is positive, then they go on forever, they don't move. So that's the infinity. For removable is a little bit more confusing because its jump is very easy. If it doesn't exist, then it's jump. For removable, it is if the first one doesn't exist. Okay, you understand? The first one doesn't exist. So let's say f of x is equal to x squared minus 1 x on x equal to normal f of x. We cannot make it 0, but 1 minus 1 is equal to 0, which means it will be 1 squared minus 1 over 0. If it's over 0, then this does not exist. See? But then for limits, it's a bit different. Because for limits of x as x approaches 1, we can change this one top. X squared minus 1 will be x minus 1 times x plus 1. Right, you see, there's a difference. You put it, you just put 0, but I can cancel it. You see, I cancel it. So 1, 1. So we 1 plus 1 over 1 will become 2 over 1 will become 2. So the limit does exist, but then the function does not. This will be removable. because you know that it goes to 2, but then this function that's not there. There should not be the function. But there is. Confusing? Yes. So this is removable. Jump is pretty easy because if the limit doesn't exist, you jump because the function exists. You know the point is there. But then for some reason one of the sides just doesn't reach it. But this one, the point is there. I mean the point is not there. But you know that it reaches 2 as x approaches 1. So when x approaches 1, it reaches 2. But then there is no function. There's nothing. You can't find anything. It doesn't exist. That's why it is removable. Because you remove it. It could have go on, but then you remove it because it doesn't exist. So that's removable. Okay, but